In this video, we'll talk about mathematical sets, kind of what it means to have a union of two sets, an intersection of two sets, and just in general, how sets work. So let's start by talking about what a set is. A set in mathematics is a really vague term. It's a collection of things. Could be the set of all triangles, could be the set of all prime numbers, could be the set of all even numbers. And a lot of these, we tie them back to numbers, but they can apply to anything in mathematics. So let's talk about a union of two sets. So let's say, for instance, I have set S and a union with set T. And this big U is a way for us to say union. What that means is essentially I'm going to take everything in set S, I'm going to add it to everything in set T, and we're going to combine it all. And in other words, we're saying something is in set S or it's in set T. So the way this is defined is if X is a member of, and that's what this little symbol means, if X is an element of set S union T, the union of the two, then X is a member of S or X is a member of T. Meaning that if there's something in the union, it belongs to one of the two original sets. And usually we represent this with a Venn diagram. So say we have set S here and we have set T here. Well, X could be just a part of S, could be just a part of T, or it could be a part of both. Sometimes it so happens that these sets have overlap. So if you think about the set of all even numbers and the set of all multiples of 3, there are multiples of 3 that are even as well. So like for instance, if S was the evens and T was the multiples of 3, well, 3 would be exclusively over here because it's not a multiple of 2. It's not even. And then 2 would be exclusively within set S because it's not a multiple of 3. But if we think about 6, that would land right in the middle. Now something that's worth mentioning, or in this case, it's the inclusive or. And that's worth mentioning because usually in English, or is exclusive. It's either this or this. It can't be both. In math, usually or would allow for the case that maybe I'm picking a number that's both even and a multiple of 3. It's inclusive. So next let's talk about an intersection of two sets. So an intersection, we would write it, let's use S and T again. We'd kind of have an upside down U to represent that. And what this means is that if X is a member of the intersection of S and T, then X is a member of T and X is a member of S. It has to fit in both sets. So on a Venn diagram, what this would look like, if you have set S and set T, X would have to be in the middle. We're only looking at what they have in common. So this would be the AND case. It has to be both. So this is a very particular one. So if we're going back to our example with the multiples of 2 and the multiples of 3, well, 6 would work. That's one that works for both. It's part of the intersection. However, 2 and 3 would not, because they're not satisfying both conditions. Real quick, let's talk about what a subset is. So a subset basically means that one set contains another set. So a way we can write this is S is a subset of T. It kind of has this sideways U. It almost looks like a C, I guess. And what this would mean is that for all X in S, X is also a member of T. That would make S a subset of T. And on a Venn diagram, what that would look like is you'd have set S, and then set T would contain it completely. So this would be if, like, for example, S was all multiples of 4, and T was all multiples of 2. The two are subsets of each other. Every multiple of 4 is also a multiple of 2. So that's just kind of a quick note. Subsets, they're worth talking about. They do pop up from time to time, and it's worth taking a second to talk about them. Now this last kind of note here, what does it mean for two sets to be equal? And if S and T, and again we're talking about sets here, are equal, what that means is that S is a subset of T and T is a subset of S, meaning that they contain the exact same elements. So, like for instance, if S was the set of all multiples of 2 and T was a set of all multiples of 2, technically they would contain each other, just barely. So on a Venn diagram, what they would look like is, well, you'd have set S, and then you'd have T overlaid on it absolutely perfectly. They would be the same exact set. They have all the exact same members.